All right, welcome to Earth Science, everybody. It's time for the Landscapes Lab, which isn't going to be Lab 26 this year, I don't suspect. So don't worry about that. We'll figure it out. So what we're going to do in this, it's really an exercise in trying to use that reference table a little bit more that you guys learned yesterday and think about some of the landscapes in New York. And then we're going to talk a little bit about watersheds and how rivers start to form. Just on the surface, don't worry about it. It won't be difficult. So here we go. We mentioned this when we did the notes yesterday. What determines the shape of the land? Landscapes are dependent on, and I promise this is going to be a question lower down on the lab. They're dependent on climate and bedrock. So it's like what is going on with long-term weather patterns on top versus what is that interacting with on the Earth. Like around here, we have this uh, relatively humid because we're downwind of a Great Lake climate with a pretty decent swing from cold to warm. You know, you guys know what it's like here climate wise. How does that interact with the layers of rock here? What if we had similar layers of rock like in a desert? Would the landscape look different? Absolutely. You know, so those two things really determine what an area looks like. You're gonna be dealing with these three or four, three and a half, maybe we'll say today. Plains, we will define as low-lying, flat, sedimentary layers. Now, what you're going to do with that, pick the right color here, is, well, that's way too big. And you don't have to draw this arrow if you don't want to. I'm just going to do it for your information. Is you're going to color those green on the map. This little bit of coloring thing. I know it sounds kind of like, you know, that's for little kids, but it helps people sort out what's going on in this map. You can do it. You'll do a good job. Plateau. Um, It's still flat sedimentary layers, but it's a mid to high elevation. So mid to high elevation flat sedimentary layers. Living this close to the Tug Hill, you guys probably know what that's like. You're going to color those yellow. So just draw an arrow right there. And now mountains. Mountains form the true mountain ranges we have. And if you were paying attention to the other one, you might have seen how the Catskills are not mountains. A mountain's what a traditional definition of a mountain is going to be hard rock, metamorphic. And I know we don't really know what that means yet. We're going to figure that out. Resistance to weathering, because it doesn't wear down very easily. If the mountains wore down very easily, and this idea will help you on the questions later on too, then they wouldn't be there anymore. The rock in the Adirondacks is very old. It's the oldest rock in the state, and yet it's still at the highest elevation. So it has not been as susceptible to weathering as some of the other rock in New York, and generally mid to high elevation. Really, most of them we'll talk about is high. Oh, one place where this always gets confusing is that when you get down, I don't know if anybody's been to New York City, Manhattan, but if you go to Central Park and see some of the rock, the bedrock exposure that's there, there's metamorphic rock. There's very hard rock. So that really like qualify as what we're saying is a mountain, and yet if you're in New York, you're clearly not in a mountain range, right? So this peneplain idea is that this is hard rock, worn down, how about eroded down to a plain, so that it's reasonably flat. Now we're going to color those two the same because that distinction is kind of tricky. And when I show you how you're going to do that in the reference table, um, it's not as complicated as it sounds. So either one of those two will be your high elevation red ones. Yeah. All right, I'm going to press pause, open the reference. All right, so here's the job. Don't worry about those letters for now. That's for some questions later on. You're going to want to get those three colors ready: green, yellow, and red. I don't know if you want to pick a less obnoxious green than that one. Probably want to do this transparency thing down like we did in the Hawaiian rainfall lab, bring that down a bit. And that's again, that's you just click this transparency, that can go up and down. That makes your pen kind of see through a little bit. So low elevation green. Now, how do you know? What you got to do is come over here and look for things that are either lowlands or plains. Keep in mind that when you go to a dotted line, your color is not going to change. That's one of the purposes of this lab too, is to say, um, practice that idea that we talked about the other day, where if you go from one side of a solid line to another side of a solid line, you enter a different landscape, different geology. When you go across a dotted line, a geologist wouldn't even notice the difference because you're just going from something that's named one thing to something that's named another. So see these dotted lines? Your colors are going to go right across those. So if I see lowlands, 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 plain, lowlands, all of those are going to color in green. So just, grab your pen, color in green, and so on. Let me mark this. People sometimes color in the lakes just to practice geography a little bit. That's Lake Erie right there. And the one that we're probably a little bit more familiar with is Lake Ontario here. So don't color those with green, yellow, or red because they're lakes. So if you want to color them in blue, go ahead, or just leave them blank and just make sure you don't color them. So greens, how do you know middle elevation? Those are going to be what are called plateaus. Plateau, and again, color across the dotted line, plateau. And then red for high will be mountains, mountains, and then cross right through those. Manhattan prong, again, I know that sounds weird, but if you just cross through the dotted lines with red, you'll be safe. Yeah, not too bad. Some questions on some of those. So, what's going on in Area C? Is it sedimentary or metamorphic, and what is the age of the rocks? Again, this should be stuff you practiced yesterday. If you didn't do yesterday's stuff, you should go back and finish that first because that's make a whole lot more sense. Um, but how do you tell? You come down here. Uppercase letters are ages, lowercase letters are rock types. So that'll give you that whole thing. Name them. Yeah, it takes a minute to write them all down, but you guys are typing now. People used to complain about this when you had to write them with a pencil. Now you're doing it on a computer, typing. You can do it. How do we know if uplift was dominant over erosion? Well, if something has gone through a whole heck of a lot of uplift but hasn't worn down a whole lot because of erosion, that means the land's still very high. So what regions would that be? Okay, watersheds. Now, because we're going in kind of a weird order this year with all the COVID stuff, we haven't quite gotten into this a ton, but let's think about this in a very basic sense. Water flows downhill. That's the golden rule. And I know it sounds obvious and silly to say that, but water flows downhill. So where you've got areas where downhill goes in different directions, you're going to have water going in different directions. And what we do is we've got some names for some of these. This black line right here, which maybe I'll highlight that in blue. And you can do this for this question instead of writing if you want to. That blue line right there is called a drainage divide. In other words, it divides the way that water drains. If you were standing on this ridge with two glasses of water, you truck them in opposite directions, water would flow down into that creek on one side, down into that creek on the other side. It divides out two drainage basins. So what is a drainage basin? That's this area right here. And I'll say that the part that people struggle with historically is remembering that it is an area of land. So I'm going to put that in caps. All drained by a stream system. Here in Pulaski, we live in the Salmon River drainage basin. All of the water that hits the ground here, rain, melting snow, whatever, ends up flowing down into the Salmon River. You don't have to go, I know you don't know why I'm pointing, but in the classroom, you don't have to go too far that way, get over into like where Grindstone Creek, where that water flows down into that, right? So what physical area of land contributes to a stream system? Keeping in mind the golden rule that water always flows downhill. All right, that's the real basic definition. So here's a map of a whole bunch of drainage basins in New York. The drainage divides are these dotted lines. So water that falls in here all contributes into this part of Lake Ontario. All of the Finger Lakes flows up just north of Syracuse. All of Oneida Lake flows up right up there. They call it Three Rivers, and then out through Oswego. We live over in these ones that just go right in. Water that goes up to the St. Lawrence, Lake Champlain's that guy, and so on. So your job here, trace in blue, in pencil, or in Magic Cami ink here. Maybe we'll do that transparency thing. The following water features. You're going to trace them and label them. And one of the purposes is to, again, get familiar with this reference table. Here it is. All of them are on there, I promise, even if you got to look around and find them a little bit. There's the Susquehanna River right there. So I'll do the first one for you, which has historically been the hardest. The Susquehanna River right down here in Binghamton, and then it flows down into Pennsylvania. That's your first one, right? So we'll say, yes, I did it. I'm going to pen a little bigger to say that this is the Susquehanna. And that's it. So we traced it in blue, and now I'm going to label it. Not an easy one to spell by any means. Susquehanna. Do that. Play with the text box a little bit. Just get it in a spot where I can spot it. I can see it. You'll be fine. Hudson River. Where is it? Go to the map. Find the Hudson River. Come back to this. Trace it in blue. Label it Hudson River. St. Lawrence, Lake Ontario, so on, so on, so on. Okay. They are all on this map. Lake Champlain's kind of a hard one to spot too. It's the skinny lake that separates us from Vermont. Right over there. And again, initially you'll ignore the letters when you're done with all of that. These questions go with those letters. All right. How many major drainage systems are there in New York? Just roughly count them up. You won't be wrong. Count them up roughly. You'll be fine. What caused the difference? The development of different drainage systems, and the idea is that water always flows downhill. That's it. So wherever, however the land is shaped, whatever the landscape is, water's going to flow downhill on it. That's it. And I know it sounds silly and repetitive, but people have this idea that water always flows south. A lot of major rivers in the United States, yes, do flow south, like the Mississippi, that all generally flow south. But I've always thought that the main reason people think that is because they're used to holding maps, like this. So if I'm holding a map like this, you get confused with south being down. If you flip a map over, all the water on Earth isn't like magically correct. Water flows downhill. End of story. Most resistant bedrock is where it is not worn down very much. What have we talked about multiple times? Where there is very high altitude rock. And if you've got old rock at the highest elevation, it must be very resistant to weathering. What factors result in the formation of landscapes? Look back up to the top lab on the top right corner. Okay, this part. All right, so what you're going to do here is draw and drainage divides separate. Let's keep it simple. People struggled with this a little bit last year. If you want to try to do all of those, cool. What I'll say to do at a minimum is the following. So I think it's easier if we rotate this map so we can see it. And what this is a picture I took when I lived out west at the Continental Divide. What this is basically the ridge of highest elevation that splits our continents in half. So standing on this sign right here, again with that two glasses of water idea, if I chucked one that way, into the picture, that water would eventually trickle down into the Gulf of Mexico and Atlantic Ocean. Whereas if I turned around and threw it this way, out of the picture, that water would trickle down towards the Pacific Ocean. It's the line that separates the two major drainage basins in the United States. So if you see all the rivers flowing that way versus all the rivers flowing that way, you got it. And we do have one little odd basin in the United States that gives us a great salt lake. But again, I'll say as a minimum, let's just say, how can we separate east flowing rivers from west flowing rivers? And if you draw a line, and it gets tight here depending on how thick your pen is and how much you zoom. It might get a little funky. I won't get too panicky. I'd say that's roughly it, right? If you want to try these other ones for St. Lawrence and those other things, give it a go. But I'd say this is like the idea of a continental divide in two major drainage basins. All of this water flows that way towards the Atlantic. All of this water flows that way towards the Pacific. Don't worry about drawing those arrows. That's just so we know. Cool. All right. No, we don't want to do that. Let's unrotate. All right, some questions. I'm thinking most of these you guys should know. I mean, this is like always an abstract idea, but water flows downhill. So if water flows downhill, what would water that hits this volcano look like from the top? Should we be able to do that? Should we be able to do that? Give them a try. See how you do. All right, final bits. How long are we going here? Okay. Going to have a little bit of reading. Now, we had some serious high water in a couple of years recently on Lake Ontario. So let's think about the Great Lakes drainage basins as part of this. And yes, I'm going to ask you to read this. It's a little bit chewy, but you guys can give it a go. Then think about some of the things that go on with Lake Ontario. A lot of people wanted to blame IJC and this plan. What do they call it? I forget, but plan. It's like named after a year. Um, but what's really going on? Like, not every, this is a complicated situation. It's not as simple as it was laid out to be. And I understand that people get emotional about it because people like lost property, people that had water couldn't access things. Um, but it's not as simple as that plan caused these problems. So let's think about what can actually be controlled on these on these various drainage basins of the Great Lakes, and what was going on. So where does most of the water entering from Lake Ontario come from? Well, so this yellow one goes that way out the St. Lawrence. If you want to draw an arrow here, that's the exit for all the water towards the St. Lawrence. So Lake Ontario is here. We've got 1, 2, 3, 4 Great Lakes that all drain over Niagara Falls down into Lake Ontario and then out. So that's a lot of geography upstream of us. So that's all the way over into Minnesota. All of that land, all of the water that lands on that land has to come through Lake Ontario. What acts as the exit or outflow for the Great Lakes that goes out there? That's the St. Lawrence River. What other drainage basin is downstream of Lake Ontario? It could be either one of those two, the St. Lawrence River or the Ottawa River. Those 2 years, the Ottawa River was a big issue because Montreal sits right here at the confluence of those two. And if this is very high, they have to limit how much water they can let out of Lake Ontario, which led to some of those issues. Name all of the places in the Great Lakes where water flow can be controlled. So this is the part that I think people don't understand. And you can find it in the reading. I'm just going to help you guys through it though. There's only two spots, and it's the Moses Saunders Dam, which is right about here, and there's one right up here. That's it. Those are the only two places where humans can physically control the flow of water coming through this system. Some people think Niagara River is one of those because there is some ways to divert it and go through. There's a canal, there's hydro facilities, and there's the Niagara Falls themselves. And they do play with that, but there's no ability to retain it, to just stop it and slow it down. It's the same, whatever is leaving Lake Erie is entering Lake Ontario, whether it go through one of those three paths. That's not a control. There's really only those two that I mentioned. Moses Saunders right there and that St. Mary's right there. So the real reason why there was so much in the system was related to precipitation and snowmelt. There was just too much water in the system. Um, you could argue that the flooding would have been worse without the controls that we had. I know, again, I know that it's politically sensitive because around here people had a tough time with that high water in those 2 years. But the reality at the end of the day is that that was all caused by record-breaking precipitation, which you can read about through that paragraph right there. But that should get you through the landscape lab, folks. Hope it goes okay. Shoot me a message if you have any questions, and best of luck.